I'm Anil Kumar, and in this video we'll answer other two questions based on flight of Osprey. In the previous video we solved from the data we found the equation of the flight of Osprey. Now let me remind you of what the question is. The question is, the following table shows the bird's height above the water as given by an observer. Determine an equation to model the data. So the data given to us was time 0, 2, 4, 6, 7 and 8 and height was 7, 10, 5, 0, 0, 3. In the previous video we found the equation from the data. The points which we used were these two x-intercepts giving rise to these two factors. The third factor we found with the help of using another point, and we utilized 4, 5. To find the value of a, we also utilized 0, 7, the y-intercept. So from these 4 points, we got a polynomial of degree 3, the cubic equation, and h of t is calculated as 1 over 6 of 6 plus 1 times 6, x plus 1 times x minus 6 times x minus 7. Now we'll utilize this model in answering other questions. So according to your model, that means this model, how long was the Osprey underwater? So that is absolutely clear. It went underwater at time t equals to 6 and came out at 7. And so it is 1 second from 6 to 7 seconds, right? So that is the value and this is the time. Second part of this question which we are going to answer in this video is, when was the Osprey more than 6 meters above the water? Now to do this question, we can adopt a couple of methods. Let me first sketch the graph. Approximately the graph for us was kind of like this, right? And here these points are 6 and 7 for us. The y-intercept is 7, right? So that is the kind of graph which we are working with. This is height and this is time in seconds. Now the question is, when was the Osprey more than 6 meters above water? So that means, let us say if this is 7 meters, then of course 6 will be, let's say somewhere here, right? So let's say this is 6 meters for us. We need to find that point. How to find this point? That is the question. So we know the equation, height is given by 1 over 6 times x plus 1 times x minus 6 times x minus 7, and we need this height to be greater than 6, more than 6 meters. So we can rearrange this. So we get x plus 1 times x minus 6 times x plus 7 should be greater than 36. That is what we need, right? So the height, which is represented by this, we just modify and we say this polynomial, let's call this the polynomial p of x. So we say this polynomial p of x should be greater than 36. That is what we are working on now. So what we can do here at this moment is, we can use calculator, plug in some values. We just need this point, right? So it is definitely less than 6, right? So we can just pick up the calculator, plug in values, and calculate from the given equation what is closest to, what value of x gives us closest to 36, right? So let's find what is p of 4. For example, right? So 4 will be in between. So we'll write 4. It is 4 plus 1 times 4 minus 6 times 4 minus 7, right? So what I will do is, I will just plug in the values, calculate on the calculator. So within brackets, we'll write 4 plus 1, bracket close. Then again, within brackets, 4 minus 6, bracket close, times 4 minus 7, bracket close, equal to, we get 30. So P4 is 30 for us. Now let's find P5. So P5 will be within brackets 5 plus 1, bracket close, 5 minus 6 times 5 minus 7, which gives us 12. So we find P5 is 12. So the answer is actually, so it is decreasing, correct? There was no point finding P5. We should go backwards, right? We should find what is before this. We are looking for 36. So we should find what is P of 3.5, right? Slightly before 4. So let's do that now. So within brackets, 3.5 plus 1 times 3.5 minus 6 times 3.5 minus 7. And that gives us, let's convert to decimals, 39.37. So 3.5, let us say we have a 0.4, which is 30. We need just 36. So we are very close, right? So that means we have to move slightly more than 3.5. So let's go 3.6 this time and calculate. So let's calculate again. 3.6 plus 1. Then within brackets, 3.6 minus 6. Within brackets, 3.6 minus 7. When we multiply all these factors, what do we get? We get 37.53. 37.53 is more than 36, right? So which is very good value. We can again try 3.7, okay? So 3.7 gives us, within brackets, 3.7 plus 1. So we are not using graphing calculator, so we have to do like this, correct? 3.7 minus 6. 3.7 minus 7 within brackets. That gives us a value which is 35.67. So that is lower than 36, correct? So from here we can conclude that that is a critical point. So this point is approximately, in the figure we've just squeezed in, the x value is approximately 37 point, we can write 5, right? So we know 3, that is more than 36, correct? So, sorry, this is the y value, 3.6. So from here what we see is that the Osprey is more than 6 meters above the water from t equals to 0 to t equals to 3.6 seconds, right? So that is the answer. So we do it by the method of induction. Just plug in the values and check, correct? That should give you a very accurate answer. I hope that helps. So in the next video we will see the slope from the tangent and also algebraically. Thank you and all the best.